with hyperbola, looks a little bit like two parabolas that are going opposite directions. They can go sideways or vertically. And there are asymptotes that form kind of an X shape that determine the shape of the hyperbola. Similar to circles and ellipses, they do have a center at hk, so x minus h squared, y minus k squared. And also similar to ellipses, there's, I'll call it an x radius, just for keeping the similarities between ellipses. So you have the x radius, which is still A, the y radius, which is still B. Very, very similar. Notice the only difference is there's the minus between. And it could also be written with the y squared minus the h squared. And the only difference between the two is which direction the hyperbola is open. If the x is first, it goes left and right. And if the y is first, if the y is positive, it opens up and down. So when you graph, it's very similar to ellipses. You will mark the center, hk, and then measure out the x and y radius in each direction, just like with ellipses. But now instead of just stopping there and drawing an ellipse, you will draw a rectangle and the diagonals of that rectangle. Those diagonals will be the asymptotes. Then you'll be able to draw the hyperbola once you have that rectangle and the asymptotes. Now remember, when you draw the hyperbola, you do need to pay attention to which direction it opens. So if the x squared was positive or if the y squared was positive. So these are both hyperbolas. We have a y squared minus x squared and an x squared minus y squared. So we're going to have one open each direction. Remember, it's over 1 if there's no number underneath your y minus k squared. So let's first pull out the center, which is hk. And you also need to be careful because h is with the x. So it's not just the order that they're written. You have to take the h that is in parentheses with the x. So that's -2, and the y would be +4. And then what we're calling the x radius, similar to ellipses, would be the number underneath the x. So that's square root of 4, which is 2. And the y radius, underneath the y, it's a square root of 1, which is 1. So we begin with the center, -2, 4. Then use your x radius to mark off 2 units to the right and 2 units to the left. And then your y radius to mark 1 unit up and down. And then that forms a rectangle going through those points. Then using that rectangle, we will draw our asymptotes. It has to go diagonal through both corners of that rectangle. For a little bit of a helpful tip, if you just count from the center, it goes 2 to the right and up 1. You can continue that as your slope. And from the center, you go down 1, 2 to the left, down 1, 2 to the left, continue that for your slope. You can do that either direction. This goes down 1, 2 to the right, continue it. So now that you have your asymptotes in place, you need to look at which direction this hyperbola opens. Since it's y squared first, that means it's a vertical hyperbola. So it will be on the top and the bottom of our rectangle. And these points that we've placed from our measuring up the x radius or y radius, so in this case the y radius, these points, those will be points of our hyperbola. That's actually the minimum and maximum for each piece. So go with your asymptote, touch the point we have marked off, and finish the curve. With the asymptote, touch the point we marked, and go with the other asymptote. There's our hyperbola. Similar over here, except remember this one will open the other direction because x was first. We'll get our center, -1, and then there's no number with the y, so that's 0. -1, 0 is our center. And then our x radius and y radius. X radius is the square root of 16, is underneath the x. Square root, you get 4. A y radius, under the y, square root of 25 is 5. So we'll start with our center, -1, 0. And then in the x direction, we'll measure 4 units each way. And in our y direction, we'll measure 5 units. And use those points to draw the rectangle, which will help us with our asymptotes. And now draw the asymptotes, which are the diagonals. So again, you could, like I mentioned on the other problem, you can count out how much it goes up and over and continue that pattern. In this case, it goes up 5 over 4. And you can continue that. Or if you just have a nice ruler, you can mark it off. Just make sure that you touch both corners of the rectangle. Then, since the x squared is first, it's positive. It's going to be open in the x direction, so along the x-axis. So it's a sideways hyperbola. And it just has to go with the asymptotes and touch the points on the rectangle. And there we go.